Hey mathematicians, so in this example, I'm going to show you a little bit more of a challenging example of the distance formula. And so I'm going to start by labeling my coordinates. So what I did up here at the top is I just labeled this first coordinate x1, y1, because that's my first coordinate. And then this one's going to be x2 and y2 because that is the x coordinate and the y coordinate of my second one. So I'm going to substitute in those values into the formula. And so my my x2, so my x2 is going to be that negative 15. I'm going to subtract x1. And then, of course, you know that you need to have that in parentheses because we're going to square them in just a minute once we get that difference. And then we need to do our y2, which in this case is going to be 33. And we're going to subtract from that our y1, which is 39. And so again, these should all be in parentheses because after we find those differences, we're getting ready to square those differences. And I just realized, I didn't highlight that, just so you can kind of see where everything came from. So the first thing I did is just substitute my x values and my y values into the formula. So my next step is that now I need to find those differences. So negative 15 minus 7 is negative 22. And then 33 minus 39 is negative 6. So now that I've got those differences, now I need to square them, right? So 22 times 22 is 484. Negative 6 times negative 6 is 36. We know we need to add those together. I'm going to keep on rolling here. I know this is getting pretty long. Once I add them together, I get 520. And we know that we need to take the square root. And typically, we're going to want that in simplest form, which for a radical means that you need to factor out any perfect squares. So what's going to make this assignment a little bit more challenging is that that's a pretty big number to try to figure out what a perfect square is, right? And you may look at it at first and be like, I'm not sure exactly what the biggest perfect square is that I can factor out of that. So enter a little something called divisibility rules. So we're looking for any of these perfect squares that'll factor out of 520. And I'm just going to start here going through 100. So divisibility rules, for lack of a better term, are kind of like a trick that helps you to figure out whether or not a number will go into another number. And I'm going to start with 4 just because 4 is a perfect square. So even if I'm not sure any other numbers that go into 520, that at least gives me a place to start. So the trick, or lack of a better term, or divisibility rule, is that if the last 2 digits are divisible by 4, then the entire number is divisible by 4. So looking at these last 2 digits, that means that I need to look at 20. Well, 20 certainly divides by 4, right? Because 20 divided by 4 is 5. So that tells me that I can factor this perfect square into the square root of 4 times whatever 520 divided by 4 is, which you guys are allowed to use a calculator, so that's going to be 130. So the square root of 4 is 2, so I know that that 2 can go ahead and come out of the radical. And now let's look at this 130. So first of all, let me go down my list of perfect squares and see if I can simplify this a little bit more. Well, the first one on the list, I would try 4 again, but 4 does not go into 30, right? 4 is not a factor of 30. So 4 is out the window. So the next one I would try is so I'm going to kind of mark that one off the list. So the next one I would try is 9 on my list. 9 also has a little trick. And the 9's trick is if you can add the digits in the number together, and that sum is divisible by 9, then the whole number is divisible by 9. Well, 1 plus 3 plus 0 is 4. 4 is not divisible by 9. So we know that 9 is not going to be a number that we can use to factor 130. So 9 is being crossed off the list. So the next one I would try is 16, but if 4 already doesn't go into 130, that means that 16 won't go in there either because 4 is a factor of 16. We know that 25 won't go into 130 because 25 would be like 25, 50, 75, 100, 125, 150. So 130 does not go into 25. And then, so I know I can mark that one off my list. And then because 4 and 9 both don't go into 130, that means that 36 won't go in there either because 4 and 9 go into 36. So the next one I would try is 49. So because 7 times 7 is 49, we should check and see, will 7 go into 130? So there's a trick for 7s as well. And the trick for 7 is a little goofy. You take the last digit of the number, so the very last digit of the number, and then you double it, and then you subtract it from the number left from the rest of the group. So what I mean by that is I would take 0. 0 times 2 is still 0. And then I would take the rest of the number, which is 13, and do 13 minus 0, which gives me 13. Well, 13 does not divide evenly by 7. So that means that 7 is not a factor of 130, which means that 49 can't be a factor of 130. So if I just multiply 64 times first of all, we know actually, I don't even need that. 64, I know won't work because 4 goes into 64 and 16 goes into 64. So neither of them worked. So that means 64 can't work. 81 won't work because we already know that 9 doesn't work and 9 goes into 81. So if 9 doesn't work, a bigger number is not going to work. And finally, 100 will not divide evenly into 130 either. So I don't really need to go ahead and, I guess I could check the next highest perfect square would be 121, which won't go into 130, of course, and then 144, which is too big. So because none of those are factors, we know that the actual, it seems like a big number. How could this possibly be simplified? But in fact, 2 radical 130 is as simple as this radical is going to get.